Good morning, good afternoon, good evening, wherever in the world you are. Welcome to today's webinar, The Power of the Clone, Scaling Out Databases Efficiently in the Cloud. I'm Janet LaFleur, and I'm here from Director of Product Marketing at Lightbits, and I'm happy to be here today with Rob Lubenthal, our Principal Solution Consultant. Rob is an expert at getting at all the critical details straight when designing solutions tailored for our customers. And what's more, he's also an expert at calculating the potential savings that we can bring our customers before we start our proof of value engagements. So say hi, Rob.
Hi all, glad to be here.
Me too. So we're going to start with a quick introduction about the barriers our customers are facing in their cloud success and how Lightbits' high-performance storage can help them break down those barriers. Then I'll turn it over to Rob, our expert. He'll dive into the more technical details on how to scale out databases in the cloud and do it more efficiently through the process of read replicas. So then we'll go into the performance and cost considerations, including some benchmarking and a TCO analysis that we did, I didn't do, Rob did, for a financial services customer. Then we'll share our Cloud Quick Start program for proof of value projects. And we're so confident that we can demonstrate success that it comes with a money-back guarantee. Finally, we'll save some time at the end to answer your questions in our Q&A session. So you can start entering those now into the chat, and we'll get to them at the end. So this is what we're seeing. As organizations build more and more cloud-native applications and migrate more of their on-premise applications to the cloud, they run into barriers sometimes. Sometimes it's performance, sometimes it's cost, and sometimes it's actually both. This is especially true for performance-sensitive workloads like your heavy-duty databases running mission-critical applications, or even just large-scale virtualized container environments. They can also be challenging. The high costs are often driven by having to go up to the more expensive storage tiers to prevent any kind of performance bottlenecks, especially as the application scales as your business grows. At the same time, native cloud storage doesn't always provide some of the data services like the replication, the snapshots, the cloning that you've come to know and love when you're on-premises infrastructure. So that is where Lightbits, one too many. That's where Lightbits for the public cloud comes in. Lightbits eliminates over-provisioning of expensive cloud storage while ensuring the performance you need for your storage-intensive applications. With Lightbits, you can scale your storage independently of your compute resources, and you'll get stronger data protection and higher availability with those built-in data services that I mentioned are often lacking. So with Lightbits, you can break down kind of the direct attach model that is available right now with external storage in the cloud, and you get more of the benefits that you're used to when having a SAN on premises, but now it's in the cloud. The resources are unified, so you can scale them collectively and not on an individual basis, and that can increase your utilization. And you won't get any additional charges for having to over-provision just to get the IOPS you need. You'll also get thin provisioning and compression, which conserve capacity. And you'll get high availability through asynchronous replication, both within and across availability zones. And last, you'll get the unlimited snapshots and clones, all at no extra cost. And that's what we're going to focus on today, the fast snapshots and clones. But that's enough about the intro to Lightbits. Let's go over to Rob, and he'll go over how you can scale out your database in the cloud more effectively with the read replicas and smarter cloning. You ready, Rob?
I'm ready. Thank you, Janet, for the introduction. So basically, we would like to take you through a real customer case we've had and to understand what it is sometimes people are driven. So this is a customer's completely loaded, everything he had, all the databases as a born in the cloud. So everything he had is running on AWS GP3 databases or data disks. And they, of course, or not of course, they were running MySQL with a read replica engine to making sure they could live up to their enormous amount of users every month and 1 million extra users. So it's really going large. And to live up to the performance, they wanted to increase and increase and increase the read replicas. But whilst they were increasing the read replicas, it became very clear that the master was getting hit by performance penalties. And if your master gets hit by performance penalties, of course, the read replicas will stay behind as well. And as an overall consequence, your full performance of the environment doesn't work, not as you would like to. Right, so that was a very big challenge of this customer. And again, right, the read replicas all there for scale out and making sure that you can fulfill the request from your customers. But if it becomes too large, you have the performance penalty in the cloud, because simply the 10,000 IOs on the GP3 in AWS wasn't cutting it anymore. So what the customer was also doing is doing a snapshot. And in this given situation, they have 7 MySQL master clusters, and each MySQL cluster had 4 read replicas, and they were running from 20 terabyte volume. That volume also had to take a snapshot. And what we also saw is that of the read replicas, only 60% of the CPU was utilized for data. And that triggered us. It's like, what if we could lift that up to 80%? What does it mean for your environment if we can do that? What if we can use your snapshot in a different manner? So are you using one of those read replicas as a purely reporting engine? So what if we can use the snapshot as a report engine, and therefore taking less load on your master? All those questions were at the customer, and we all had to look for, okay, how can we do things, and how can we enable faster storage with less cost? So then we had to look into the AWS, right? Because what we want to do basically is having the snapshot and make a clone of the snapshot, so we could mount that clone as a reporting engine database, and not getting the updates from the read replica anymore. Because hey, it was reporting, and it could sustain a 12 or 24 hours delay. So that was not a problem. So we dove into what can we do, and we found out that, hey, if we create a snapshot from the GP3, it creates the data, or it sends the data to the S3 bucket. But once it sends the data to the S3 bucket, that also claimed IOs from the GP3 disk. And we wanted to find the IOs. We wanted to have more IOs available, and we wanted to reduce the latency. So serve faster the data to your customers and keep happy customers. Right, and then the next step was, okay, let's even if that's the case, and we can still offload the load from the read replica to reporting engine, what if we can create a clone from it? So how can we utilize that S3 bucket to become a disk again? That wasn't so easy. So basically what you have to do, you have to retrieve the data from the S3 bucket onto another hard disk or an SSD disk. And now it's becoming interesting, because number one, it's not instant. Number two, you have to pay for the other hard disk or the SSD you're using. And number three, you got to pay for extra cost of the retrieval of the data from the S3 bucket. So rather than having all these consequences and delivering a fast response, we found out that on the 20 terabyte database they were running, there was no way we could have copied the data as fast enough back to the SSD or hard disk, because the network wasn't allowing it. And that drove us to do different things. So what if we can do things differently, and what if we can help you moving to achieve your target? So we sat down and basically said, we're not just looking, we keep the read replicas as this. We just want to focus on your reporting engine, see what we can do there, and free up the data. And number one, of course, your master SQL, let's put it on a Lightbits volume. Not anymore on GP3, but let's put that in a Lightbits volume. Once it's on the Lightbits volume, we speeded up the process of the master. There were no more read replica delays, and the customer really liked the idea of having the reporting structure, because when they did the read replicas, and the reporting, some of the reporting structures and some of the read replicas had blocking issues. They needed to have an environment where if some query was done or some inserts were done, whatever, it could have blocked some tables, and therefore the read engine couldn't continue, and it wasn't not the best solution. So there was another cool thing with the read replica or with the smart clone we did, is that number one, it's instant. So we lifted, so it's instant. No more delays, no more pain. It's there. No more copying data, because we do it differently. We do redirect on write inside the system. I'll explain to you a little bit later how that works. But also we've lifted up the IO's limit on the GP3. But there's no physical limit. It depends on the number of disks you have underneath the Lightbits. So it depends on what kind of instance from Lightbits you choose. I also wanted to do, if we can lift up 4 times 60 is the same result as 3 times 80. And what do we mean with that is if we can lift up your CPU utilization to 80% rather than 60%, I need less instances on AWS, right? So rather than having the 4 read replicas, we moved back to less read replicas, and we had the clone as well.
And that's where the savings come in, right?
And that's indeed where the savings come in, right? So, and that was a massive saving, basically what we will show, and I'll show you later. But also with the smart cloning, we have reduced the 500 terabytes to 225 terabytes. So it is instantly a savings on all benefits, because the way how we basically do it. So if we have a look on how we basically do it, then when you create the snapshot inside Lightbits, we just copy the metadata. We don't do data replacements. We don't copy data out, because there's no change. And if there's no change, what's there to copy, right? So this is basically it, right? So on the left side, you have your volume, and in the middle, you have your metadata, which points out where your data sits, where your blocks are, where your data is contained. And on the right side, it's a snapshot. So when you create a snapshot, nothing's changed. It's all the same. We just create the metadata. And then the cool thing starts if once you start making changes, like I'm making a change on the snapshot or the clone in this case, and let's say I had C, or the original volume changes block C, you can see that it makes a C apostrophe and points that to the C apostrophe, whilst the original volume, Janet, or the clone just stays on the C, because that's not a change. So we maintain the data, we don't touch. So even if you got 500 clones there, right? Or we don't care how many clones you create, right? I think it's up to 24,000. So at the end, we do care, but before you do 24,000 clones, you've run out of other stuff as well, right? So that should not be the issue.
Yeah.
And that's what it is, right? So this still points to that C1. And there's no performance penalty, no nothing on it. But the cool thing on the performance penalty or on the performance, if I just pick on the other one, because what we could do, right, if we have the clone, I could create data on the clone. And now the original volume stays at A, and the same behavior counts to the clone. He just creates a new block metadata a pointer, and that's A apostrophe. But the cool thing is, look at the BD. Hasn't changed. So if for any chance, right, the clones were fetching the data from the B, it sits in our cache engine. So when any other clone or original volume points to the same block or same metadata pointer, we already have the block in cache and serve it out directly without hurting any NVMe disk in the background. So that is indeed, it's not just space savings, right, which is money savings, but it's also lifting up your performance and reducing your pain on the performance end as well.
And does Lightbits charge? I mean, I'm being a shell here. Does Lightbits charge to do this process? Because I know some of the cloud providers.
No, it doesn't, right? So that is the good thing. And basically, how Lightbits is, we're not charging for snapshots and the clones, right? It's all in there. There's no extra features, so all the soft features we have comes inclusive. And the cool thing is, depending on your orchestration tools, we integrate with your orchestration tools as well, right? So like it's Kubernetes or it's OpenStack or it's VMware, it's all taken care of. So right, so you don't have to learn new things in your way of managing your storage. That is another benefit we have. So now talking about performance and cost, right? So let's zoom into that a little bit more. What did it mean for this customer, and why was he pretty happy about it, right? So there's one thing what we provide with Lightbits, and that's sustained low latency, and this gives you a predictable performance, and that's what you want to have. And even if you got to look at this, right? So for e-commerce or fintech companies, right, when the demand goes high because of Black Friday, you want low-level sustained performance, right? Because you don't want any delay on your websites to make sure that you keep your customer. And if your response is too slow, especially in those most important weeks, you don't want the customer to hop to another website and buy the product somewhere else. You want to have it here, and you want to attract more, keep people to you. Right? So that's basically what we do with Lightbits. We do make sure that, depending on, or not depending, but we keep delivering your latency and your data as fast as possible without having spikes. And we've got a lot of secret sources inside the how we treat it. And don't forget, right? We're native NVMe TCP end-to-end. We're the founders of the NVMe TCP protocol. There's no delays. There's no changing of protocols in the middle, right? So it's not like we do some stuff on our own and our storage, and we have to convert the protocol from NVMe to our own detailed native protocol. Now it's just end to end, and that makes it so very fast and very performant, right? So having said that, then this is basically what we achieved, right? So we lifted up 72% of the reads. The inserts were 22% faster, and select and updates were 15% faster. And it was just and this is on IoT Block Express, right? So even with performance benchmarking we've done and other big sites, we're just better off. And that means that the customer has a better performance and better sustained response to your databases and to your customers. And so that is that one. And for this company, it was like, there are a couple of benchmarks which are very important. Number one, they get 1 million new borrowers every month. And the granting of a small loan has to be within 10 minutes. That's their internal goal, right? So, because otherwise, if they were not doing it within 10 minutes, they will cause delays and the risk of not keeping the customer happy, and they would go somewhere else. And that's, it's like borrowing money, and you have to have all the credits and all the checks of the person. Is the person liable enough to pay back the loan, that kind of stuff? Within 10 minutes, it's awesome. But there's another thing as well, is that in the market they're in, at the end of the month, or when people get paid, they are sending an email to all those people, or a text, or however the communication is to that person, to that borrower, to make sure that, hey, it's time to pay back your money. Because if they don't, the money is gone, and they have to wait for another 30 days before they're getting paid, right? So that's another really picking up, making sure that we do, or they can send all the notifications on time and retrieve their money. Very, very important for them. And that's another area where we could help them by making sure that, again, the low latency did help to live up to the performance requirements they had. And that's all fine. And it's all benefits, but surely, you have to make sure that it's not just performance fine, but you have to make sure that the cost of ownership is efficient as well and makes an impact in the right direction. So what we saw is that in this angle, right? So the storage cost we reduced with 26% due to being smart, due to doing the clones, doing the snapshots in a different way, and reducing the number of required disks. Also, we could do more with less. So yes, we are running storage instances in AWS. You have to pay for that as a customer. There's no other way. We're using the NVMe disks inside the AWS environment or Azure environment. But it's the way back. It's also what is it we can do? What is it we can clone? What is it we can use a snapshot? So I don't have to use a snapshot on the S3 bucket anymore. I don't have to retrieve it. So my network costs are less in Azure AWS. And the other benefit was we could reduce the instances. And by reducing the instances, again, 4 times 60 is the same as 3 times 80. We just, in this case, we reduced 20% of the costs. So the overall total cost was 25% less. But then if you look at the cost per a million IO, dramatic savings here, right? And you could say this is soft savings. But this customer is now not concerned on scale out, doing more, load heavier loads, create databases differently, and it's sustained, it's fine, low level, constant, same performance, predictable, and that's what I didn't have, right? So that is all these things the customer's pretty happy with, to make sure we could achieve it. So that's for this customer. Was fun, and yeah,
I can see how that would make a big difference for their business, and managing their read replicas with better snapshotting is a big part of that. So that's good.
Yeah.
Well, thanks, Rob, for the thorough rundown. We're just going to summarize, and then we're going to go into our Cloud Quick Starter bundle, and then questions. So start typing in your questions. We have a few come in, but I'd like to answer some more. So to summarize it all, Lightbits delivers the fastest block storage available on AWS or Azure with the highest throughput and that consistent low latency that Rob was talking about. So you can handle the Black Friday or whatever the demand generating event in your business is, and it scales. And with Lightbits, you'll get more predictable, lower cost, and you'll pay on a consumption basis. You won't have to over provision, either IOPS or by volume. You can probably end up using fewer EC2 or Azure VM instances, and that can reduce your database and application licensing costs as well. You'll get the flexibility of being able to scale performance and capacity independently. And you'll also gain this SAN in the cloud kind of advantage of managing resources as a pool, while you get those enterprise data services that we've been talking about, the thin provisioning, the compression, and of course the free snapshots and clones that we've been focused on this in this talk. All that is at no additional cost. And then finally, if you do choose to use Lightbits on an on-premises environment as well as in the cloud, our licensing supports being able to choose where you deploy it. So finally, let us prove Lightbits' value with you. To prove the value to prospective customers, we're offering it's a new offer with a risk-free guarantee. So we're guaranteeing that you will see superior performance in your cloud environment at less than half the cost of a native cloud storage. We call it the Cloud Quick Starter Kit. 3 steps. We schedule a 30-minute appointment to kind of understand your workload and your overall environment. Then we'll assess whether we think Lightbits, can deliver what we're saying here, and we believe it will probably. And if we do, then we will move on, and you can purchase this Cloud Quick Start Kit. The sizing depends on your environment and how much it costs. And then we will test and optimize everything to see how it can, how it works, and then deliver a comprehensive report that shows your expected performance and TCO savings. And finally, this does come with this guarantee. So if we meet the requirement, if we don't meet the requirements, you have the option of getting your money back. But if you do choose to move forward with us, then you will be credited, of course, for what you've invested into this Cloud Quick Start Kit. So it is time for questions and answers. Let me check and see if there's any new ones since I last checked. Okay. Rob, I think this is probably related to the performance numbers you showed were for MySQL. But anyway, the question is, what kind of performance do you get with Oracle? And this person uses AWS. So if you have Oracle AWS numbers, they were most interested in that.
Yeah, okay, that's a good question. So basically, we've done a lot of performance benchmark, a lot of different databases. And it doesn't really matter which database you use. The volumes or what we can achieve per volume in AWS and Azure is 1 million IOs against the low latency, as we described. We've done another webinar on this. Was that the power of or the database wars, or that was like something like that, Janet?
Yeah, Speed Wars.
All right, the Speed
It's
Wars,
like,
that was the
yeah.
one. And where we do show, the performance benchmark we've done with Oracle as one of them. But again, right, we are agnostic to database engines. We try to run what they're asking us to do.
Okay. Yeah, somebody was asking whether databases, and if I remember right, in that Speed Wars webinar, there was Oracle, MySQL, and MongoDB. So
Yeah.
those at least 3 of them, and there may be more.
Yeah. And there will be more. And I know that the guys are working hard to show different numbers with other databases as well. So we keep on investing in that.
Yes, we have a Sagi Volkov as our database expert, and we keep him very busy. Or actually, our customers do, because everybody is using different environments and different databases. Okay, and then the question about Azure. We are available. Are you available in Azure? This one came in fairly early, and the answer is absolutely yes. Another one is about what does setup and management look like? Yeah. What is this? How do you set up and manage your Lightbits cluster?
So that's interesting, right? So basically, how we set it up, we are part of the marketplace in AWS and in Azure. So basically, it's just go through the marketplace. You click you want to install it. It's completely self-installable, or you allow the application to install it. If you allow the application to install, we would just create all the networks we need to have. We create the database, we create the instances as storage instances, and we mount the cluster, and you get fully enabled storage available for you. So that's basically how simple it is. You have to choice to do it all yourself. But you have the easy way. Is it like, okay, I'm going to create Lightbits cluster. I want 3 to 16 instances in the cluster. You choose your instance type, and we take it away.
Yeah. And then I also want to let you know that on Azure, we also are available as a managed service where Lightbits will do the monitoring and a bunch of other activities to
auto healing, auto scaling, right? That's all features which are there. Yeah.
Okay. Last call for questions. Well, I think that's it for today. Thank you, Rob, for joining us, and thank all of you out there all over the world that are watching us today for sharing our experience here with the Power of the Clone webinar. Thank you.
Thank you.